So this is a fairly common question on resistance voltage characteristics. This one in the middle, this is following Ohm's law. Things that follow Ohm's law include resistors and wires. Then other components don't follow Ohm's law. And that's because, like this one here, this is a light bulb or filament lamp. And the reason why it doesn't follow Ohm's law is because the resistance does not stay constant as you increase the current. And the reason for that is because the wire inside gets hot. After all, it is nothing more than a wire, and I've just said graph B is of a wire. Well, a lamp is using a wire. That's what the filament is. But the difference is that this wire gets very, very hot, and so the resistance doesn't stay constant. Now, we know that as it heats up, the resistance increases. So what's happening here is the gradient is reducing. So it starts off steep and gets less steep. So what is the gradient in this case? Well, the gradient is going to be the change in y over the change in x. That would be the change in the current over the change in the voltage. Resistance is voltage divided by current. So that would mean the gradient is actually 1 over the resistance, because as you can see, that is that, but upside down. So if we plotted voltage on the y-axis and current on the x-axis, we'd see a shape like this one here. And I've labelled it incorrectly to show that if you had these two graphs side by side, which one would be correct for a filament lamp? It would be the one on the right, because the gradient is in fact reducing, because the gradient is 1 over the resistance in this case. And so we'd expect the gradient to go down. For high values of resistance, 1 over a large number is a small number. So that's what we would expect. It would gradually get less and less and less. So yeah, okay.